I'm going to be working on problems 6, 7, and 8 from F35 midterm exam practice number 1. So this is all about domain, range, and end behavior. So let's start with the top. You want to, for each of the functions below, you want to find the domain and range of the parent and the transform function. So here we have f of x equals x squared plus 8. The family and parent function, well, we see that it's x squared, so we know that the family is quadratic. And looking back at our notes, we know that the parent function for quadratics is just yx squared. If you go back to these notes, you can see here that our domain is going to be all real numbers because it's going all the way left and all the way right. And our range is going to be y is greater than or equal to 0 because we're just going up. We don't have anything, our function doesn't go down here, it's just up. So when we go here, domain and range of parent function, our domain is going to be all real numbers, and our range is going to be y is greater than or equal to 0. Now here in our transform function, we're adding 8. It's outside parentheses. That means we're going to be moving up 8 units. So if you look at the parent function, that means it's going to go up 8, and then it's going to go like this, right? So our domain is going to remain the same because it's still shooting left and right. So our domain is still going to be all real numbers. But our range now is going to start at 8 and shoot up. So we want f of x to be greater than or equal to 8. Okay, because we shifted up. All right, if we take a look at g of x equals 1 over x plus 4, if we take a look at our notes, we remember that that's from the reciprocal family. And if you look back, our reciprocal family is just y equals 1 over x. Y equals 1 over x. Here we see that the domain is x is not equal to 0 because here we have an asymptote and we can't divide by 0. So therefore our domain is x does not equal 0. And our range is y doesn't equal 0 because we have another asymptote right here. Okay, so our domain is x is not equal to 0, and our range is y is not equal to 0. Now for this transform function, we have 1 over x plus 4. This plus 4 is considered inside the grouping symbol, inside parentheses. So therefore, that means that we're moving this reciprocal function 4 units to the left. So now instead of having this, we're moving 1, 2, 3, 4, so now we're going to have something like this. Okay? So therefore, our domain is now, we can't have negative 4 in the domain because we can't divide by negative 4. Here, negative 4 plus 4 is 0. We can't divide by 0. So x cannot equal negative 4. We didn't move it up or down, so our range is still going to remain the same. Our range is still going to be that g of x cannot equal 0. Okay? The vertical asymptote is still at 0. All right, finally we have h of x equals square root of x plus 15. Here we see that the family is square root. And looking back at our notes, we know that the square root parent function is just y equals square root of x. If we take a look at our notes, square root looks like this. Therefore, our domain is going to be x is greater than or equal to 0 because we start at 0 and we want to go to the right. And our range is going to be y is greater than or equal to 0 because we start at 0 and we go up. Okay, we're not going to the left or down, therefore that's why we just have this as domain and range. So our domain is going to be x is greater than or equal to 0. Our range is going to be y is greater than or equal to 0. Now for this transform function, we're adding 15 inside the square root, inside the parentheses. Therefore, we're going to be moving left units, left 15 units. So here, this function is going to start over here at negative 15 and go this way. So that means that we want our new domain to start at negative 15 and go right. So our new domain is going to start at negative 15 and go right. So therefore we have x is greater than or equal to negative 15. But our range is still starting at 0 and going up. So for our range, we're still going to have h of x be greater than or equal to 0. Okay? Because we just moved it left and we're still going up, but we started at 0 and going up. Okay? All right, so that's number 6. Number 7 is about end behavior. Given the graph of the function below, we want to figure out what happens to y when x is approaching negative infinity and when x is approaching positive infinity. So let's take a look. As x is approaching negative infinity, that means as it's going really, really left. So as it's going really, really left, what's happening to y? Well, y is going up. So when y is going up, y is approaching positive infinity. Okay? So it's going up. As x is approaching positive infinity, that means it's going really, really right. So as it's going really, really right, what's happening to y? Well, our y is going up, so therefore y is also approaching positive infinity. It's going up. Okay? And finally, we have number 8. We want to sketch a function where as x is approaching positive infinity, y is approaching negative infinity, and as x is approaching negative infinity, y is approaching negative infinity. So what this is saying is that as it's going really, really right, our y values have to go down. So as it's going to the right, we want our y values to go down. So something like that, right? It's going right and down. So that's what it looks like on this side. Now as x is approaching negative infinity, so as it's going really, really left, it's telling us that it still wants to go towards y is approaching negative infinity, so it's going down. So as it's going left, we want it to go down, so maybe something like this. An upside down parabola, so a quadratic reflected across the x-axis. You could also have something like an absolute value going down, or anything of the sort, as long as the end behaviors are going down on both sides. On the right is going down and on the left is going down.